Welcome, ladies and gentlemen. So what I'd like to do is show you how to solve a system of equations by graphing. Now, the two problems I chose, in this example, we're going to have one equation has no solution, and the other equation has infinite many solution. Because in my previous video, I showed you how to find, solve the system, but when they actually did intersect. So one of these examples, my two lines are never going to intersect, meaning there's no intersection point, meaning there's no solution. And the other one, the two equations are going to intersect infinitely, meaning they're exactly the same line. So therefore, there's infinite many solutions. For whatever x and value that are on the line is going to be true for both equations all the time. So when you're solving a system of equations by graphing, the best thing to do is obviously graph them. But to determine if you have the same line or if you have parallel lines, you have to put them in slope-intercept form. You could actually use different forms for standard form, but I don't want to get into that. That's a whole different discussion as far as using a, b, and c and values for that. But I think the best thing to do, which something you're familiar with, is to rewrite these in slope-intercept form. And we don't even need to graph this because, as I told you, when you are going to graph, and let's say you didn't know that one of these was no solutions or infinite many, you would automatically get going. And once you start to look to graph them, you don't need to graph the points, and you can determine if it's no solution or infinite many. And I'll explain once we write them. But the first thing we need to do is write them in slope-intercept form. So 7y equals 6, and negative 3x plus 21y equals negative 18. So we want to solve for y for both of these. So here my y is being added by x, so I'm going to subtract an x on both sides. So I have a negative 7y equals negative x plus 6. Now I undo, divided by negative 7. So I'm left with y equals a positive 1/7 x minus 6 over 7. Interesting equation. It would not really be fun to graph that, right? So let's go and solve this one. First thing we're going to do is add a 3x to both sides. 21y equals 3x minus 18. Now we'll divide by 21. And when doing that, I have 3 divided by 21, which reduces down to 1/7 x. And negative 18 divided by 21, let's see, 3 divides into both of those. 3 divides into 18 a negative 6 times. 3 divides into 7, 21 times. So that becomes 1/7 x minus 6 over 7. Now, you can see that these are exactly the same equation. So you can graph them. It's not going to be fun. You'd go down to 6/7, which is almost at 1, and then up 1 over 7. So it's going to be a very slow slant here. But it doesn't matter. Since these graphs are aligned, you're graphing the same line on top of each other. So the graphs are going to intersect infinitely. They're on the same line. So it's what we call infinite many solutions. So whenever you're getting to graphing to solve, when you find out they have the same solution, you can just write infinite many solutions. So you might say, well, this one has to have no solutions. Well, let's go and take a look here first, because even though that's the purpose of this video, you never know until you get to it. So let's go ahead and solve them for x, or to put in slope-intercept form. OK, so to solve for y here, I need to undo subtracting 2x. So therefore, I have a negative 3y equals negative 2x plus 15. Now I need to undo dividing or multiplying by negative 3. So I'm left with y equals 2 divided by 3 is a positive 2/3 x minus 5. OK, now to go ahead and solve here, I'm going to subtract an x. Subtract an x. So I have a negative 3/2 y equals negative x minus 3. Now, how do you get rid of a fraction? You can divide out the fraction, or the same thing is multiplying by the reciprocal. So I'll be multiplied by negative 2/3. Multiply this whole thing by a negative 2/3. So that multiplies to 1. So I'm left with y equals a negative 2/3 times negative x is a positive 2/3 x. Negative 2/3 times negative 3 becomes a positive 2. So you can see that they have exactly the same slope. However, they are not exactly the same line because their their y-intercepts are not exactly the same. So whenever you have two equations with exactly the same slope but different intercepts, they are parallel lines. Let's go and graph. Negative 5, 1, 2, 3, 4, 5, up to over 3. looks something like that. This one, up to over 3. So they're going to be parallel lines. They're never going to intersect. So therefore, this is an example of no solution. So just to recap, when you are solving a system of equations and you have to graph, when you have them in slope-intercept form, or even if they're already in slope-intercept form, see if you can rewrite them in slope-intercept form if they're exactly the same. If so, it's infinite many solutions. If they have exactly the same slope, but do not have the same y-intercept, then they are parallel, and there is no solution. So there you go, ladies and gentlemen. That is how you solve a system of equations with no solution or infinite many. Thanks.